Okay, so there are two types of steam turbines. The first category is called impulse turbine. The second category is called reaction turbines. In impulse turbine, there is no pressure change in the rotors. Rotors are moving blades. Okay. There are two types of blades, rotors and stators. Rotors are the moving blades, stators are the fixed blades. For impulse turbine, there is no pressure change in the moving blades. That is, in the moving blades, delta P equal to 0. Moving blades. But in reaction turbines, there is a pressure change. That is, pressure increases or pressure changes. Actually decreases. Pressure changes in the rotor. That is the moving blades. So delta P is not 0 in the moving blades. Okay. So this is the broad category based on the pressure change in the moving blades. If there is no pressure change in the moving blades, those turbines are called impulse turbines. If there is a pressure change in the moving blades, the turbines are called reaction turbines. Now, let us see for a simple turbine how the flow takes place. Before that, I would like to discuss the notations. U refers to the blade speed, blade velocity or blade speed. So, small u refers to the velocity of the blade. Now, C refers to the velocity of the fluid. The absolute velocity of the fluid. I will write it as a vector. Now CR vector refers to the relative velocity. Okay. Now this is the relative velocity in the moving blades. There is no concept of relative velocity in the fixed blades. There is only relative velocity in the moving blades. Now the definition of relative velocity is CR is the velocity of the fluid, the absolute velocity of the fluid minus the velocity of the blade. So this is the relative velocity. It is the velocity of the fluid relative to the blade. So this is the definition of relative velocity. In the velocity triangles, you have to see this particular relation. If you rearrange, you will be getting I will not erase this particular relation. This is very important. If I add the relative velocity and the blade speed, I am going to get the absolute velocity. Is this clear? Now let us see how flow takes place within the turbine. This is the moving blade or the rotor. Now, if I draw a tangent to this, this is the direction of relative velocity. In order that there is no flow separation, straight up, in order that there is no flow separation, the relative velocity vectors have to be aligned with the particular blade direction. So this is tangential. This direction is a tangential direction. That is to this particular blade. For smooth entry, the relative velocity has to be along the tangential direction to the blade. So, for smooth entry and exit, the relative velocity CR has to be along the along these tangential directions to the blade. Now, say I'll tell you how to draw the velocity triangles. If this is the relative velocity at the inlet, CR1, and say this is the blade speed at the inlet, U1, then CR1 plus U1 will give you CA1. Are you there? So if I add these two vectors, I will be getting this particular vector. I'm wrong, only adding this. Sorry. CR1 should be aligned with the blade. So this is CR1. Now this is U1. U. Now this added to this will give me CA. Using triangle law, this vector plus this vector will give me this particular vector. Okay. Now at the exit, this is CR2 and this is U2. So this will be CA. Using triangle law of addition. So actually, what are these velocities? What are these velocities in the triangle? U is the blade speed. This blade itself is moving at a speed of U. That is the speed U, and the speed here U1 and U2 are same. That is the blade speed. Now CA1 and CA2 are the velocities of steam as seen by a person on the ground. If there is a person who is sitting on the ground, he is going to see the steam coming at this velocity CA1 and the steam leaving at velocity CA2. CR1 and CR2 are the velocities of steam as seen by a person sitting on the blade. If there is a person who is traveling with the blade, he is not going to see the velocity CA1 and CA2, but he will be seeing velocity CR1 and CR2. The person on the ground will see CA1 and CA2. The person on the blade will see velocities CR1 and CR2. Okay? So this is the velocity triangles, and while drawing the velocity triangles, I use the rule CA is equal to CR plus U. By triangle law, this vector is equal to this vector plus that vector. Again here, this vector is equal to this vector plus that vector. We should take care that this relation is obeyed in the velocity triangles. Now we are going to define angles. The angle made by CA1 with the tangential direction, I call it as alpha 1. The angle made by CA2 in the tangential direction, I call it as alpha 2. So the absolute velocities make angle alpha 1 and alpha 2 with respect to the blade speed direction, that is the tangential direction. Now the relative velocity vectors make angle beta 1 and beta 2. Okay. So these angles are beta 1 and beta 2. And angles are measured with respect to the tangential direction. This is the tangential direction, or this is the world direction. Because the blade is going to whirl. The blade is moving like this, that means that is the world direction. To find the world direction in any flow, you just have to see the blade speed. The blade speed is along this direction, that means there is a whirl along that particular